So I can't take the square root of a negative number. I can't divide by 0. That's the issue that I got to deal with here when I'm looking for domains. So they're asking me to take, first off, for part A, and they're telling me to divide these two fractions. Well, or two equations. So I've got the top one, and for that top one, I've got 1 over the square root of x. Well, there's a couple issues going on here. I can't divide by 0, so x can't be equal to 0. So that's a limit on the domain. I also can't take the square root of a negative number, so that tells me x has to be greater than 0. Okay, so that's the stipulation that I've got from the numerator. Now in the denominator, I can't divide by 0, so what I'm going to ask myself, when is that equal to 0? Well, if you remember back some work you did in Algebra 2 or College Algebra, whoops, sorry, not 4, but 2. Guess I got to try to erase this here, and if it'll let me, there. So, x minus 2, x plus 2, that's the difference of 2 squares. So, when x equals positive 2, there's an issue. When x equals negative 2, there's an issue, because that's when it's equal to 0. But I've already said that x has to be greater than 0, so that's not a non-answer. So if I'm going to talk about the domain, I have to have an open bracket, and I guess they are telling me to use interval notation. So open bracket 0, and then it can't be 2, and I'm going to skip over 2, then I'm going to go out to infinity. And that takes care of the domain for part A. So for part B, I cannot, let's see, they want me to find that composite function. 1 over, let's see, it's p is the outside function. Square root of x squared minus 4. So I've got that embedded. So I know I can't take the square root of a negative number. I know I can't divide by 0. So basically what I'm going to ask myself is, when is x squared minus 4 greater than 0? Because it can't be equal to 0 and it can't be negative. So same deal. I know, well, I'm going to do the factoring root. So x plus 2, x minus 2. Okay, that has to be greater than 0. And then, so we know the problems are negative 2 and a positive 2. So one way to deal with this is, because I'm going to assume you don't know what the graph of x squared minus 4 looks like. You probably do, but I won't go there yet. So I'm going to basically try numbers in this range and see if I get a positive number or a negative number. So let's see. Let's try a number to the left of negative 2. Well, if it's left of negative 2, like negative 10, negative 100, it'll be negative. If it was negative 10, that would be negative 8. See, I'm just plugging them back into my function right here. And I should write that more clearly. Okay, so if I substitute in negative 10, I get a negative number. If I substitute in negative 10 here, I get a negative number. And negative times a negative is a positive. If I try a number in the range between negative 2 and positive 2, like 0 is a good candidate. That would be a positive number times a negative number, which gives me a negative answer. So that would tell me it's below 0. Then if I pick a number to the right of positive 2, like 10, that would be a positive number times another positive number. So that gives me a positive number. So this tells me that for part B, I have to use, I'm going to use interval notation. So I'm going to go from negative infinity to negative 2. And those are open brackets because they can't be equal to 0. And then I'm going to skip over that to positive 2 to infinity. And that is going to be the domain of part B. Now you could try graphing this function and you would probably see that is indeed true. Alright, for this last one, they asked me to find the domain of m of p of x. So I'm going to drop the p function into the m function. So 1 over the square root of x squared minus 4. Well, if you square square root, you get 1 over x. Okay. And a couple things we could do. Let's see. One issue that comes up is in the original function, I couldn't have, in that original p function, the domain was limited to be, x has to be greater than 0. Okay, so that same domain issue falls into this new composite function. So even though if I look at this graph, and I could plug in anything but 0, and I would get a number that works. So because of that limitation, because of this original limitation in the p function, that same domain limitation is going to follow through here. And what I'll do in a second is I'll graph this, and I'll show you the graph how the domain for this part C is also going to be x has to be greater than 0. So in interval notation, it'll be 0 to infinity. Open brackets for both. So I graphed these two functions out of Desmo.com, and notice here's the original f of x, and here's the g of x. So then I'm dropping f into g, which gave me that, remember that 1 over x plus minus 4. So the domain of this function, if I'm just looking at this part of it, would be anything except x equals 0, right? But if you know, as you can see here, when I graphed the composite, it held to that old domain issue of x has to be greater than 0 here, and that's what we're seeing. So you got to be aware of what's happening in the parent functions when you're looking at the domains of the parent functions when you're looking at the domains of the composites. So I hope that helped you solve these problems.